In this video, we're going to talk about what it looks like when you have an inequality with infinitely many solutions. So let's just dive right into an example here. I'm going to solve this inequality just like I would any inequality by getting the variables on one side and all the constant terms on the other. So to get the variables on the same side, I'm going to add 2m to both sides. And notice what happens. The negative 2m and positive 2m cancel on both the left and the right, leaving us with just 14 is greater than 7. We have no more variables, and so we have to just look at what does this inequality mean. 14 is greater than 7. This inequality statement is always true because 14 will always be larger than 7. So anytime you get rid of your variables and you have a statement that is always true, in this case 14 is always bigger than 7, that's when you have infinitely many solutions. So this is really similar to our no solutions, except no solutions was when you had an inequality statement that was never true. Now we're looking at inequality statements that are always true. Let's look at the next one here. Let's try and simplify it by combining some like terms. So I'm going to combine negative 2d and positive 5d. So we get 3d minus 2 on the left-hand side. The right-hand side will stay the same. Now let's try to get all the variable terms on one side, all the constant terms on the other. So let's go ahead and subtract 3d from both sides. But again, just like the previous example, you'll notice that it cancels out on both the left and the right. We're left with negative 2 is less than 8. This happens to, again, always be true because negative 2 will always be smaller than 8. So that's how we get our infinitely many solutions, when you get an inequality statement that is always true. So this one, infinitely many.